I guess to answer your question directly, you always need a database for your AI apps. Yeah.
The Shift, Agentic Edition, connects the people building AI tools with those creating agents so we can all level up together. Today, we're taking a beat with the Microsoft Azure team, James, Jared, Debbie, and Nikisha, to talk openly about a question we heard from you. Wait, my agent needs a database?
Wait, what? My agent needs a database? I kind of joke that it's like agent palooza right now. There's a lot of emphasis around building these AI apps, building AI agents, standing up agents internally or customer facing or whatever. So what are you guys seeing in terms of that shift?
So I think what we're seeing is there's a lot of effort being spent on the databases themselves in order to empower these new sort of search methods, right? So traditionally databases always had, I want to do a point read, or I want to read a particular row of the database, or I want to execute a query. And now we're just seeing more and more ways of how to pull the right data at the right time, specifically to empower these agentic applications. And then for MCP servers, we're seeing all these great sort of modalities of how do agents interact with the database. We know how developers interact with the database, and we know how DBAs interact with the database and applications interact, but how should agents interact with the database, and what's that interface look like? And that's where a lot of the development of MCP has really been focused.
A lot of people have questions about how does this change what I've been doing? How do I bridge this gap into bringing all of these skills and these tools that I have and make them work in this new generative agentic model way?
I think something that might surprise people is how it's really touched every part of our portfolio of databases. You may have heard of PG Vector and Postgres, or what Cosmos DB is doing for AI. But even Azure SQL now has the capability to do vector search. And so it's really kind of across all our databases that we're seeing this.
All the search modalities, you can find in Azure Postgres or Azure SQL or Azure Cosmos DB. Vector indexing technology, those developed at Microsoft, DiskANN. Right? You see that in all of the Azure databases now. So it's really interesting seeing a lot of search modalities and data processing steps, right? Like the integrated vectorization that you have in the Azure AI extension from Postgres, or the pipelines that we're building in Cosmos DB. All those data processing pipelines coming directly into the database itself.
It's really helpful to think about how we got here, because so much has changed in such a short period of time that if you can't keep track of all of these progressive technologies, it can make it more difficult to make the right decisions moving forward. It's really helpful to think about how we got to this place and why vectors are important and why vectors drive this new frontier of capabilities. The AI models that we use today, they don't necessarily understand language the way we do, but they do understand representations of concepts. What vectors do is they take these words and these concepts and they allow the models to store them so the models are able to interpret and understand them. You're converting all of the data that you have in your systems of record or your databases into these new data types, these vector embeddings that the models are able to use. But that takes some thought and some planning, and you have to now incorporate a vector store into your ecosystem somewhere.
Okay, let's take a step even further back then, because for software developers, they've had to wear all these different hats, right? Like 10 years ago, you were like, I'm just coding my app, that's it. And someone else dealt with data, I had a DBA. And then it was, I don't know, within the past 5-10 years, suddenly I am the DBA, because now as a developer, I have to think end to end. But it's okay, because I still had my data science team, and they handled analytics and machine learning and AI. They were over there, and it's like, oh, shoot, now all of a sudden that's in my app now too. So now I have to understand this stuff. Can we explain for everyone who's listening or watching, like, how is data used and leveraged within AI apps and agents?
For generative AI apps, and we'll say, apps that are using a large language model as an agent or a small language model or something like this, data is really important to act as an efficient way to personalize that or contextualize that agent or that large language model for your scenario.
Well, when do I need a database? Whereas when can I just use stuff that's in blob storage or colder data? Any guidance as to when we need a database and when we're okay with something else?
For a lot of companies, a lot of their crown jewels and their information is stored in an existing database. And so when they think about bringing agentic capabilities to their existing applications, there are different ways to do that. You can fine tune a model and train it specifically on that data that you have, but that brings a whole set of challenges and responsibilities. Or another approach is you can bring a specific relevant subset of the data that your application is aware of and present it to your model in such a way that the model can reason and add more value to you by using the existing databases that you have with some new concepts like the RAG approaches of taking subsets of your data and presenting to your models to bring that together.
Yeah, and there's some great benefits to that because, like you say, you don't need to copy it somewhere else, and you've got your data in a place where it's already highly available and performant for queries and secured, which is great when developers think about, wow, we're hoping to expose all this corporate data to an AI model. How do we keep it safe?
Yeah. I mean, I guess to answer your question directly, you always need a database for your AI apps. Yeah. Like generative AI applications, they're different. It's a different paradigm. Fundamentally, they're still applications, right? So if I have transactional data, if I have analytical data that I want stored, the reason for using certain databases is still there. Right? If I want a really strong relational database model, I might want to use Azure SQL, or if I want the extensibility and open source sense of Postgres, like that's something that's really appealing. I want flexibility of a NoSQL database, like automatic sharding and scalability, right? Cosmos DB is a great option. So those sort of fundamental reasons of why you want to power an application using a particular database, they still hold in the generative AI space. What we're just seeing is that a lot of the technology now to empower new AI scenarios is also being brought into the database layer itself with, as we're talking about semantic search and all those other capabilities as well.
SQL does now have a vector data type and function so that you can actually do vector search there. And another thing that's come up is we have a native JSON implementation in SQL now, which is super helpful that really is the language of AI models.
Yeah. And I think sometimes when you're new to embracing these new technologies, you're not aware of what your databases can do and what the new capabilities that are already built into your frameworks and database systems are ready to offer. Certainly with Azure Postgres, there are all of these extensions that are available that the community has contributed, that the Microsoft research team has contributed. And vector indexes and vector databases are really fascinating technologies because once you look into them, you can see the similarities that they have with approaches that you might be familiar with if you are a database professional. You don't have to be intimidated by these new ways of working with new technologies.
Can you unpack that a bit more? Like, what are some of the similarities?
Yeah, that's a great question.
I've never heard anyone actually explain it like this before. I'm fascinated.
Traditionally, when you're working with a database, you're usually presenting a query that contains a filter or a predicate to narrow your search results.
Yeah.
You're usually looking for something specific. That same challenge exists when you're working with large language models, when you're trying to find a specific set of data that you want to present to your model, but you're now looking in a different data type environment. You're now looking at these vector embeddings. So the same kind of SQL processing isn't applicable. There's a different approach, but the idea of indexing that data still applies and it's still important. And there are a number of different ways that have been applied to creating vector indexes. I think what Microsoft has done specifically in creating DiskANN, where we've taken these foundational principles and we've combined the best of both worlds in order to provide people with the best performance, the best accuracy, and the best scalability.
Yeah. So, Cosmos DB is this non-relational database that powers Azure, powers so many different scenarios in Microsoft, like Microsoft Teams, powers scenarios outside of Microsoft. We have Walmart running on Cosmos DB. We have OpenAI running, 50 something workloads on Cosmos DB. And so the fundamental reasons why Cosmos DB is so well loved for these transactional and really sort of large scale scenarios and workloads are also apply to when we bring these new search capabilities in. So, initially we brought in vector search into Cosmos DB and made the DiskANN vector index generally available. And this wasn't the first time that it was available. Consumers have been using the DiskANN vector indexing algorithm in things like Microsoft Office solutions or like in Bing multimedia search, right, to do search at really enormous scale. Bringing that into the database, we're able to leverage the value propositions of Cosmos DB. So low latency, scalability, automatic sharding, auto scale, serverless capabilities, all this great stuff.
I think to Jarrett's point, a lot of technologies that have been in databases for a while around full text search and filtering, we can combine those with vector search to really make your search smarter.
Climb every mountain, Debbie. I like it.
And then to be even able to share those investments across platforms. So if you're working with a Cosmos environment, that capability is available to you. If you're working with a SQL Server environment or an Azure Postgres environment, those same capabilities and efficiencies are available, and you have the freedom of choosing the right platform that is right for your organization's needs.
Whether it's transactional queries in Cosmos or analytical queries in SQL and Postgres, right? And having sort of this core framework, again, lends itself really nicely for bringing those advanced search capabilities into the database.
And there's really no right answer of the question, do I need to take my data and bring it to my model, or can I bring my model to my data? So that ability to have that freedom of choice in using each one of those approaches, depending upon what makes sense for your application or your team, is a really great capability as well.
So James, earlier you said, basically like an app's an app essentially, right? And apps are going to need databases. What I've noticed, at least in speaking with partners and customers and everyone, is that the technical requirements of this new wave of apps and these AI apps and these agents are very different, almost table stakes and mandatory. Like, what is the level of scalability I have? Can I support AI scale, right? Can I actually handle real-time data? What's been fascinating as somebody who, works across the entire portfolio of our databases is seeing this kind of almost convergence of a lot of these like similar requirements and then the capabilities and features. However, that does make me wonder then, from our original question was, wait a second, my agent needs a database. Well, then what kind of database does my agent need? How do we actually start to think about, as developers, SQL versus Postgres versus, a non-relational database like Azure Cosmos DB? Are those walls coming down, do you guys think?
There are definitely more and more bridges that are being developed. What I think is challenging, and I think where a lot of people can spend time ensuring, is the responsible aspects of building these new generative systems or agentic systems.
So the core reasons why a developer might pick, say, Azure SQL or pick a non-relational database or a Postgres database, those still hold in those applications themselves. When developers pick like a NoSQL database like Cosmos, like they're looking for very specific things, right? Like we sort of like to say that DBAs don't like Cosmos DB since it's a fully managed database, right? So like we shard and partition your data for you automatically, and we have auto scale and geo replication. So it's really this database that sort of grows with you and scales with you. And so if you are planning for cost efficacy or these sort of transactional scenarios, Cosmos DB has that core value proposition, right? Now, if I need a relational database, of course we have Azure SQL, which is really this massive workhorse of a database inside Azure.
Yeah, there's some great reasons, for instance, to choose Cosmos, like the chat history scenario that you were talking about later. It's just built for that kind of unstructured data. But a really great thing about having these vector capabilities in our other relational databases is that you can bring generative AI and bring vector search to applications that you already have.
Yeah, and this probably actually paints a picture where it's like there's actually lines being blurred or the walls are coming down really between databases and search engines or search services, right? Like we'll see customers using things like an Elasticsearch or a specialized search engine or a specialized vector database that sits on top of their original data store. And now that they're able to keep their operational data or their original data in one place and perform like advanced search capabilities on that same database, they're really seeing simplification of the application architecture. The sorts of searches and data retrieval mechanisms that I want to use are just available in the database natively. So this makes my app simpler, saves me on costs, saves on development and upkeep, reduces another point of failure, keeps my data consistent. I don't have to worry about ETLing my data from one database to another data store, keeping things in sync. We're bringing those capabilities into the database itself.
Another great enhancement that has come about recently is the standardization around MCP servers. And so developers can really just learn one thing. There's a standard now for how they can connect their databases to their models and use it like an API. So they almost have like an endpoint for their data that the model can easily talk to.
being able to understand why the model is responding the way it is, being able to guarantee that the model is free from introducing biases or introducing responses that could be deemed or termed unsafe, being able to ensure that you have transparency in your model and security. Those are all concerns that now application teams have to concern themselves with, but are the core features of building those guardrails are going to be available in those databases that we're providing today.
Going back to your original question about like developers and what developers want from, say, a database or from sort of a data hosting service, right? So I can think about it in like multiple sort of layers. So one layer, developer might say like, okay, well, I want something that satisfies both the functional and non-functional requirements in my app. There's different methods of being able to recall something. If I want to write a query or I want to do a semantic search, and then there's the non-functional requirements as well. I need to do this in a certain latency. My searches and my queries to be lightning fast because I don't want to wait any more time waiting for my LLM to give me a response. I want it to be as fast as possible. Or I want geo-replication because I want my customers in Singapore to have the same latency as my customers in LA. We can think about it from like a functional and non-functional sort of a requirement standpoint. Things that developers enjoy working with, or developers need the right tools for where they are, right? So having, rich SDKs and, whatever language is of their choice, whether it's Python, which we're seeing a lot of generative AI development in, or JavaScript, which is also really huge, or if they're running enterprise applications in Java or .NET. So having a rich ability to interact with the database in the way that developers expect from their applications. And of course, this translates also to things like the new generative AI frameworks that we're seeing. So no matter who you are as a developer, no matter what application stack that you're building on, you can build your applications and interact with Azure databases. Not just satisfy the requirements of your app where it is, but as it grows.
Earlier, you had said that the benefits of bringing all these new capabilities into the databases, it helps with simplification. I don't have to like stitch together 18 different things, right? But doesn't MCP actually make it a lot easier for us to go and use a whole bunch of different technology? And in which case, then what is the benefit of having all of those like baked into a database or a specific service?
I think a good way of looking at MCP is just seeing it as like an interface for agents to interact with some service, sort of like an API is or an SDK. And in an MCP server, you get to define as broadly or as narrowly as you want a set of tools that the agent can then call, and also instructions on how to use those tools. So I could ask an agent to go write a bunch of code using the Azure SDK and interact with my database. But I can probably get better results if I have some well-structured tools with some guardrails around the type of behaviors that I want, and a good set of instructions for how an agent can use those tools to do what it needs to do on the database itself.
The MCP server is really opening up new scenarios in terms of connectivity. You can connect to Foundry, as James was talking about earlier, take advantage of all the models that are there. And so really broadening your set of tools that way. We just announced actually that we have a new version of PostgreSQL coming soon, a new product, Azure Horizon DB, that takes Postgres to new heights of scalability. So I'm super excited about that roadmap and about getting that in customers' hands. It's coming to preview real soon.
We launched a ton of stuff at Ignite. One really cool capability is Cosmos DB fleets. To actually provision and maintain and manage entire fleet of multiple different Cosmos DB resources and database and containers. And you can also share your resource units, like share your compute across like that fleet.
I love it. Any misconceptions that you want to, this is your opportunity to clear something up. What do devs need to understand that they don't now about your products or databases or any of that?
One thing I think that is really important for developers to be aware of that they may not know about when working with Postgres is that Postgres is actually an object-oriented transactional database engine. And so what that means is you can take a lot of the principles that you might be familiar with working in an object-oriented development environment and take those same core concepts and apply them as you're modeling your database objects, which can provide a lot of gains in efficiency and performance and reusability. It's really exciting and it's important that people know.
For developers either building applications with some dynamic workloads or building out like their first MVP of an agentic application, we have Cosmos DB serverless, which is incredibly cost effective, right? I think it's somewhere around like, I did this computation one time. It's like you can insert 100,000 vectors and do 100,000 vector searches and it costs less than $250 $2.50, less than a cup of coffee. We're in New York, so less than a quarter of a cup of coffee in New York, I guess. But it's just incredibly cost effective to get started now. And then of course that database can scale with you as your application grows. So really, there's a lot of great work the team's been doing.
I love that.
Yeah, if I had to think of one misconception people might have, it's that SQL Server may not have all these great capabilities that we talked about for Azure SQL. And actually the great news is that all the AI capabilities for vector search and functions and for JSON, et cetera, that I talked about earlier are not just in Azure SQL, they're actually in SQL Server 2025.
Yeah, that was really impressive what the team has done with SQL Server 2025. It's really changed the game and really brought that engine into this AI era. It's really cool.
Thanks for hanging out with us. Check out the link below to get our ebook about building a strategic database ecosystem. See you next time.